Good morning, boys and girls, and here we go, back for round 3, section 2.3, techniques for computing limits. This is probably kind of about where you ended in trig pre-calculus with computing limits. So we're going to kind of just jump right into it. If you wanted to compute the limit as x approaches to 6x minus 1, say, okay? We've got a bunch of different methods we can do algebraically. Well, first, again, quick review. We could do this graphically. We've talked about that as one method of doing it. I could graph that function. We could do it numerically by plugging in values that are very close to 2, like 1.9999999 and 2.000001, and make sure that as I come from both the left and right hand side, right, because this is a two-sided limit, make sure that those are approaching the same value. But we can also do this algebraically, okay, and that's probably a better method here. And when you're solving a limit algebraically, the very first thing you should try each and every time is direct substitution. You want to go ahead and you just want to plug in where you're trying to find the limit. Like in this case, I would plug in 2, and in this case, I'd get 11. So the limit as x approaches 2 in this case would be 11. Okay, 6 times 2 is 12, minus 1 is 11. So always try direct substitution first. I say that, and I'm saying it over and kind of over again, because as we move on to the more complex ways of doing this algebraically, sometimes you forget the easy one, direct substitution. Always try this first. If this doesn't work, then we're going to try other stuff. And what I mean by it doesn't work is I mean I get an indeterminate solution or an indeterminate situation. Indeterminate situation. Okay. Here are some of our indeterminate situations. If I plug into the function, if I plug in for my limit, and I get 0 over 0, or I get infinity over infinity, these are two of our most common ones we really want to watch out for. These are going to pop up a bunch, okay? But there are others. If I get 0 times infinity is indeterminate. 0 times infinity is not 0, boys and girls. Hate to break it to you. We're going to get more into infinity down the road. Same with infinity minus infinity. That is not 0. Not all infinities are the same size, believe it or not. Kind of crazy. Or infinity to the 0 power is not 1. Okay, we don't know what that is. Or better yet, 0 to the 0 power or 1 to the infinite power. Okay, all these things. These are things that are indeterminate. We really don't know what they are. I know this blows your mind, but we cannot say that like 1 to infinity is 1. Okay? 1 to any power, any finite power is 1. But if you go to infinity, is it really 1? We don't know. I don't know. I'm looking at my picture, not at you guys. I don't know. Kind of weird. I know. I'm still getting used to this video stuff. I kind of like having my picture in here, though. I don't know if I like looking at me. But I think it helps to look at me and see my animation a bit. I don't know. Okay. Next now then. So if I get this indeterminate situation, though, now I got to try some stuff. So what would you try? I don't know. Let's zoom. Oh, geez. Let's zoom in over here. So kind of learn how to use this. You could try. If you get indeterminate, try. Factoring is a very common tool that we have. If you factor and kill stuff off, that oftentimes will take care of your situation. Okay? If you can't factor or that's not working, you can try simplifying what you're trying to take the limit of. Oh boy. Where'd my stuff go? Insert. Draw. My eraser's here. Simplify. Okay, try simplifying. Put stuff together. Maybe that will fix your situation. If that doesn't work, or if you generally if you see square roots, hint, hint, wink, wink, okay, then you're going to want to try to use the conjugate. Okay, if you don't know what the conjugate is, remember that if I have root 3 plus 1, the conjugate of that would be root 3 minus 1. We just switched that sign on the inside. Those two things are conjugates. Okay? Conjugates, right there. But those are 3 of the most common algebraic things that we're going to use to try to do that. I'm also going to tell you, pause the video right now. I want you to turn to page 77 in your book. there is a big old list of limit laws right there. I'm not going to write them all down. I'm not going to waste the time. You've got them in the book to look at. They are fairly, I think, kind of, I don't know, not self-obvious, but they seem to follow in line with a lot of things we've done before in math, so they don't tend to give us a lot of issues, I'll say. Okay? But look on page 77 in your book for that, the list of limit laws that we need to be aware of. All right? So with all this being said, that's our quick little intro for today. Now, let's go and get back, and let's kind of do some problems. So, problem number 1. The limit as x approaches 1 of negative 2x plus 5. We said if we were going to evaluate this limit, the very first thing we should try to do each and every time is to, you got it, plug in. So negative 2 times 1 plus 5, hey, that gives me 3. Okay? So the limit as x approaches 1 in this case would be 3. If we evaluate like this, we know that that's going to make that two-sided limit be true. All right? Number 2. 22. All right. The limit. Here, I'm going to pause this for a second. I'm going to set up 22 because it's a little bit of writing, and I don't want to waste a ton of my time. And then you guys will be able to catch up in a second. So I'm going to pause it. You'll see me back in just 2 seconds. All right, boys and girls. Here's that problem I promised you. Number 2 here. I'm giving you the limit as x approaches 1 of f of x, and I'm telling you that is 8. The limit as x approaches 1 of g of x is 3, and the limit as x approaches 1 of h of x is 2. I'm telling you those limits. I want you to use that information to evaluate the limit as x approaches 1 of all this stuff here. F of x over g of x minus h of x, and then tell me the limit laws you use to evaluate this. Okay? So again, I'm going to pause. I think I'm going to write the step, and then I'll come back and we'll talk about the law I just used. Okay, there would be my first step. I could be very judicious with my minutes on this thing. Using this would be the quotient law. If I have a fraction that I'm taking the limit of, I can take the limit of the top and the limit of the bottom. Okay? So in this case here, that's going to work out kind of nice because I know the top, limit of x approaches 1 of f of x, is 8. So now I could just plug in 8 for that stuff. Now I've got to use one more property. I'm going to pause and write this one up here. And I'm back with everything now. So down here again, I split up the bottom part now, and I said the limit as x approaches 1 of g of x minus the limit as x approaches 1 of h of x. Okay? And that is using the difference property, difference law of limits. So again, I think these things are kind of halfway intuitive, so I'm not really worried about it. But my idea is I'm going to try to break these things up so that I know these limits individually. The one for f of x was 8, we said. The one for g of x is 3, and the one for h of x is 2. So this whole thing would equal 8. The limit of this thing is 8. Okay? We use our laws to evaluate that. The main law I think I really want you to be focused on and really kind of know the name of / be able to use is this quotient law. Come the end of the semester, that's going to come back into play quite a bit, and we're going to have to write things like that. So maybe do be aware of that one. All right, here. I'm going to pause again because I got more to set up for the next problem. Okay, here's our next problem. The limit as x approaches 3 of x squared minus 2x minus 3 all over x minus 3. Okay, so we said again, the very first thing I should do on a problem like this is I should try to plug in, try direct substitution. If I plug in, I'm going to get 9 minus 6 minus 3 is 0, over 3 minus 3 is 0. I get 0 over 0. Right? And again, technically what I'm doing right there when I did all that, I used that quotient rule we're talking about. And eventually down the road, I'm going to have make you show a little bit more work, again, towards the end of the semester for that part right there. But I get 0 over 0. That's an indeterminate situation, so I don't know what the limit is. I've got to do more work. And so we said, when you have to do more work, things that you should try. Hey, we should try factoring. Hey, this one looks like one I can factor. I am sorry, boys and girls, but you are going to need to rewrite this limit thing every time. I know you guys think it's a giant pain in the butt, but every time you rewrite stuff, you need to, again, get used to one, working vertically. I know I put that equal sign there, and I've been doing that a little bit, but we want to try to get away from that. Equal signs on the AP exams can get us into a lot of trouble. If we say two things that are equal that are not really equal, they'll dock us, okay? So try not to use equal signs, or at least setting things equal to each other. Be careful of that. Do rewrite your limit every time. I know it's a pain, but we got to do it. But that's part of showing good math work. We're becoming great mathematicians is what we're doing. All right. Now that I factored, though, I could kill off the x minus 3 and the x minus 3, creating a hole in my graph, right? And so now I'm really looking at the limit as x approaches 3 of x plus 1. And now I'm going to try direct substitution again. And what do you know? That works. I get 4. So the limit of this thing up here is 4. And again, because those things are equal, I can't put an equal sign there. I just want to equal things that are not equal together. That'll get us into trouble. All right, so there's a direct substitution one / with factoring. Next one will pop up in a second. Okay, here's our next one. The limit as x approaches 1 of 2x minus 1 quantity squared minus 9 over x plus 1. Again, whenever I get this, first thing, try direct substitution. In this case, I'm going to get, if I plug in 1, I get 2 minus 1 is 1 squared minus 9. Oh, shoot. That's what I thought. Sorry. Correction. That, again, if I did direct substitution on this one, I'm going, oh, I'm not going to get an indeterminate solution. That's awesome. But I made a mistake. This really should be to the, I want to evaluate x as -1. So if I do -1, 2 times -1 is -2, times minus 1 is -3 squared, is 9 minus 9, or again, I get 0 over 0. Again, going back to what I said not to do last time, this is where you would get into trouble. I'm saying things are equal that are not equal. Okay, that would be bad news on the AP exam. Okay, we're going to want to just look, though, and that's I'm trying to show you what I'm thinking. But if I plugged in here, I'm going to end up getting 0 over 0. And so that's another indeterminate scenario. So what I want to do is I would try to factor, but this is like kind of already factored, and it's not really helping me. So another thing we said you could try is simplifying. If I simplify this, hey, 4x squared, that's going to be minus 2x, so minus 4x plus 1, minus 9 all over x plus 1. And then I put that together, and I get, 4x squared minus 4x minus 8 all over x plus 1. And then I do the limit. I know writing this every time is a pain, but I do it so you can do it too. All over, if I factor at the top, I can take out a 4. If I took out a 4, that'd leave me with x squared minus x minus 2, which if I factor that, that's going to give me x minus 2, x plus 1. So with a little simplifying, and then I had to factor this time, I'm able to kill this thing off again, and now I'd want to plug into what I have left over. If I plug -1 in now, I get 4 times -3, or this is going to give me -12, and there's my answer. Okay, so sometimes simplifying mixed with factoring, all that kind of good stuff. All right, one more, the conjugate. And again, I got to pause because I have about 2 minutes left. Okay, here we go. Last problem. The limit as h approaches 0 of the square root of 16 plus h minus 4 over h. If I plug in, I'm going to get my 0 over 0. So indeterminate. I need to do something more with this. Again, whenever you see this square root, that is a good sign that you're going to have to use the conjugate. I want to take this, and so what I'm going to do is, like we used to rationalize the denominator, I'm going to kind of, use the conjugate on the numerator. And I'm going to multiply both the top and bottom by the square root of 16 plus h plus 4. That's the conjugate. The square root of 16 plus h plus 4. I'm going to pause and do some work and come back again because we're at 1 minute left. Okay, I went and I finished up the problem here because I figured you could pause this and go back and look at my work. And I'm trying to keep these to 15 minutes, and you can look as you need to. But I used the conjugate. I multiplied by square root of 16h plus 4. I had to double distribute, so so I put parentheses up there, and I got this right here. Then when I simplified the top, I was just left with h. Notice I didn't multiply the bottom. Don't multiply the bottom, because when you do this, generally stuff is going to kill out, and the conjugate is going to be left right there. And then now I can evaluate, and I can plug in 0, and when I do that, I get 1 over 8. Okay? Look that example over, look my work over, and if you have questions, you can pop in and see me. We're at our 15-minute mark. These are the techniques you will use to evaluate limits. Have a nice day, and you can now try the homework. Bye-bye.